In this lesson we're going to look at how to solve equations with fractions in them. Now, equations with fractions look complicated, but there's an easy way to eliminate the fractions, and I'm going to show you in this lesson just some basic examples, and then we'll move on to more complicated ones later on. So let's look at this first example here. We've got half x equals 9. Now, the most common mistake is to think you halve the 9 and x is 4.5. But if I was to say on this side that a half of 4.5 equals 9, that wouldn't make any sense. What we really have to do is undo the halving. And to undo halving in mathematics, the opposite of halving is doubling, or timesing by 2. So we're going to times this side by 2 to undo the half, and we're going to do exactly the same to the other side, times by 2. So this is going to give us x, and on the other side we're going to get 18. So let's think about this and put it back in. A half of 18, or half times 18 equals 9, that's right. And this process can be used all across this top line. We want to undo a third, we times by 3, but we must do the same to the other side. So a third times 3 is just 1, so you just get 1x, and that equals 21. To undo the fifth x, you times by 5 to both sides. So these cancel out, that's like timesing by 5 and dividing by 5, so that just gives you x, and that equals 5 lots of 12, which is 60. Okay, let's move on to these more complicated looking equations. Now, the way to do this equation is exactly the same as the one above, we just have to do it more times. So if I'm saying that I want to undo the half x, I need to double it, or times it by 2. But because we've got an equation here, we've got an equal sign, we must do the same to all terms in the equation. So I want to double that one, and I want to double that one as well. Now that I'm doing the same to all things, if this was on a balance, like a set of scales like this, and it was going like that, and this is not very good, but roughly, as long as I doubled all the things on both sides, these two things would be on this side and this would be on this side, you'd still have a balanced scale. It would still be equal to each other as long as I did the same thing to every single thing on the scale. I'll just get rid of that. So if I double this, I'm just going to get x. Double the 3 and I get 6. Double the 14 and I get 28. Now I've got an easy equation to solve because I've eliminated the fraction. Take away 6 from both sides, x is 22. We do the same process in this equation here. We want to undo the quarter, so we times by 4. But to keep the scales balanced, or because we've got an equal sign here, we need to do it to every single term. We need to multiply this by 4, and also this by 4. So this just gives us x, 1x. Take away 20, and 4 lots of 12 is 48. Remember to do the opposite here of take away 20, which is add 20, so x is 68. Okay, last two examples. Now again, if you look at this, this is the number here we want to multiply, we want to eliminate the fraction. So we want to multiply by 3. The only difference this time is we've got a 2 up here. So when we multiply this by 3, we're really having 2 divided by 3 times by 3, so that just leaves us with a 2. In other examples, when we times by 2, we're left with a 1x, and times by 4, you're left with a 1x because there's a 1 up here. But in this one, because we're timesing by 3 and it's 2/3, then we're left with a 2. But remember to times everything by 3, so the 5 times 3 and the 11 times 3. So 2x plus 5 3s are 15, and 3 11s are 33. Take away the 15 from both sides, so 2x is equal to 18, and half your answers, so x equals 9. Same idea here, 5 in the bottom, so we want to undo dividing by 5, so times everything by 5. Remember to do it to every single thing. and again I will be left with the 3 here. So 3 divided by 5 times 5 is just 3. So 3x, take away 2 times 5 is 10, equals 40. Add the 10 to both sides, so you're going to get 3x equals 50. So we're going to have to divide by 3, so x is equal to 50 over 3. 3 doesn't go into 50 exactly. And then simplify that down, and that's going to be 3, 7s are 21, 3, that'll be 16 and 2/3. So 3 times 16 will give you 48, and then 2/3 left over.